Lesson 4.2, angles of triangles, starting on page 250. Number 1, find the measures of each numbered angle. So by the angle sum theorem, the three angles of any triangle must add up to 180 degrees. So if we add these other two angles together, 63 and 59, we would get 122 degrees. And if we subtract 122 from 180, that would leave us with the measure of angle 1, which is equal to 58 degrees. Number 3, find each measure, find the measure of angle 2. So in this problem we have to apply the exterior angle theorem since we're given an exterior angle, 112. And the theorem states that the exterior angle will be equal to the sum of the two remote interior angles, or the two non-adjacent interior angles. Since this angle is adjacent to 112, we wouldn't add those two angles, we would add these two. So if we add these two angles together, the measure of angle 2 plus 32, that should be equal to our exterior angle, which is 112. So to solve for the measure of angle 2, we would subtract 32 from both sides, and the measure of angle 2 is equal to 80 degrees. The brace of this deck chair forms a triangle with the rest of the chair's frame as shown. If the measure of angle 1 is 102 degrees, so we can write that in, 102. And measure of angle 3 is 53. Measure of angle 3 is 53. Find each measure. So for number 5, we want to find the measure of angle 4. So we would have to apply the exterior angle theorem. Since we have angle 1, that's the exterior angle. That angle will be equal to the sum of the two remote interior angles. So 4 and 3 are the remote interior angles, since 2 is the adjacent interior angle. So if we add 4 and 3 together, let's see, the measure of angle 4 plus the measure of angle 3, that should be equal to our exterior angle, which is 102. So if we subtract 53 from both sides, the measure of angle 4 would be equal to 49 degrees. So 49 degrees for that. Number 7, to find the measure of angle 2, since we now know what the measure of angle 4 is, 49, and we have the measure of angle 3, we can add those two angles together and subtract them from 180, and that will leave us with the third interior angle. So if we take 53 plus 49, that would be 102. And if we subtract 102 from 180, that would leave us with 78. So the measure of angle 2 is 78 degrees. For number 9, to find the measure of angle 1, we would apply the corollary to the triangle sum theorem, which states that in a right triangle, the acute angles must be complementary. So we have the measure of angle 1 plus 29 equals 90. So the measure of angle 1 will be equal to 90 minus 29, or 61 degrees. On number 11, to find the measure of angle 2, we notice that we have a linear pair here. So angle 2 and 29 are adjacent along this straight line, so they must add up to 180. So the measure of angle 2 will be equal to 180 minus 29, which gives us 151 degrees. For number 13, to find the measure of angle 1, we would add these two angles together and subtract them from 180. So 120 plus 30 would give us 150, and 150 from 180 gives us the measure of angle 1, which is 30 degrees. So in number 15, we can find the measure of angle 2 by subtracting 31 from 90. Since we have a right triangle, by the corollary to the triangle sum theorem, the acute angles must be complementary. So 90 minus 31 leaves us with 59 degrees. So the measure of angle 2 is 59. Therefore, the measure of angle 1 would be 59 because 2 and 1 are vertical angles. We have intersecting lines and they are non-adjacent. So they are vertical angles, which must always be congruent. And then we can add 59 and 22 and subtract that from 180 to get the measure of angle 3. So 59 plus 22 gives us 81 degrees, and 81 from 180 gives us 99. So the measure of angle 3 is 99 degrees. For number 17, we'd apply the exterior angle theorem. Since angle 1 is an exterior angle, it will be equal to the sum of the two remote interior angles. So this angle is the adjacent interior angle. These are the two remote interior angles. So if we add those two together, we would get the measure of angle 1, which is 79 degrees. Once again, we will apply the exterior angle theorem. Since 92 is our exterior angle, it is equal to the sum of the two remote interior angles, which are 2 and 71. So the measure of angle 2 plus 71. If we subtract 71 from 92, that would be the measure of angle 2, which is 21 degrees. On 21, we want to find the measure of angle ABC. So ABC would be this angle. In order to find this measure, we have to solve for x. So we have an exterior angle, 148, which is equal to the sum of the two remote interior angles. So 148 is equal to these two angles added together, A and B. So that would be 2x minus 15 and x minus 5. So we can combine our like terms and get 3x minus 20. We can add 20 to both sides. That gives us 168 equals 3x. And we divide both sides by 3. And x is equal to 56. Once we have x, we want to find the measure of angle ABC. So ABC is equal to x minus 5. So substituting in 56 for x, we get 51 degrees. Number 23, suppose the wheelchair ramp shown makes a 12-degree angle with the ground. What is the measure of the angle the ramp makes with the van door? So we have a right triangle, so we can apply the corollary to the triangle sum theorem, which states that the acute angles in a right triangle must be complementary. So 12 plus x, or plus question mark, is equal to 90. So if we subtract 12 from 90, we would find our angle, which is 78 degrees. To find the measure of angle 2 on number 25, we know that we have a right triangle. Since we have a right angle on this side, the lines are perpendicular. So we have a right triangle here, excuse me, and therefore our acute angles must be complementary. So if we subtract this acute angle from 90, we'll get the measure of angle 2. So 90 minus 51 gives us the measure of angle 2, which is 39. To find the measure of angle 4, we know that we have a right triangle, so these two angles must be complementary. So first we have to find the measure of angle 6. To find the measure of angle 6, we have to find the measure of angle 5. So we have a right triangle here, so these two angles must be complementary. So to find the measure of angle 5, we subtract 35 from 90. And we get 55. So to find the measure of angle 6, since these two angles are complementary, because we have a right angle, they must add up to 90. So we would subtract 55 from 90, and we're back to 35. So the measure of angle 6 is 35 degrees. And once again, a right triangle, these two angles are complementary, so we subtract 35 from 90, and we're back to 55 for the measure of angle 4. For number 31, to find x, we need an equation. We have a right triangle, so our acute angles must be complementary. So our two angles here, x and 2x, must add up to 90. So if 3x is equal to 90, x is equal to 30, so our variable x is 30. We substitute that back in to get our angle measures. So our angle measures would be x, which is just 30, and 2 times x, so 2 times 30, which is 60. Number 33, a landscaper is forming an isosceles triangle in a flower bed using chrysanthemums. She wants the measure of angle A to be 3 times the measure of angle B and C. What should the measure of each angle be? So, in an isosceles triangle, that means we have at least 2 congruent sides. So our 2 congruent sides would be AB and AC. So B and C would be congruent. And we don't know what the measure of angles B and C are, so we can call that x. So if B is x, then C is also x. And A is 3 times the measure of angle B, or 3 times the measure of angle C. So that would be 3x. So by the triangle sum theorem, we know that these 3 angles must add up to 180. So our equation would be x plus 3x equals 180. So combining like terms, we get 5x is equal to 180. And if we divide by 5, we get x is equal to 36. So that's the measures of angles B and C. And the measure of angle A, we need to substitute in 36 for x, so 3 times 36 would be 108. For number 35, we want a paragraph proof of corollary 4.2, which states, given a triangle, in this case triangle MNO, and angle M is a right angle, then there can be at most one right angle in a triangle. So the corollary states that there can be at most one right angle in a triangle. So we would say in triangle MNO, angle M is a right angle. And we know that the measure of angle M plus the measure of angle N plus the measure of angle O is equal to 180. That's by the triangle sum theorem. That's true for all triangles. Since angle M is a right angle, so the measure of angle M equals 90. So if we subtract 90 from this, then that means that the measure of angle N plus the measure of angle O equals 90. And let's just say that N was also a right angle. So if N were a right angle, and we substitute a 90 in here, then that means that the measure of angle O is equal to 0. But this is impossible, so there cannot be 2 right angles in a triangle. On 37, we need to find all of these missing angles. So it really doesn't matter where we start. Let's just start right here, since we know that this angle is 110 degrees, and we know that this angle will be its supplement. So the measure of angle 7 is 180 minus 110, or 70 degrees. And from there, also we have vertical angles. So this angle is vertical with 110. So the measure of angle 5 is also 110. Let's see where we can go next. So if 5 is 110, and this angle down here is 30, so together that would give us 140. So the measure of angle 4 is equal to 180 minus 140. These two add up to 140, so 180 minus 140 is 40 degrees. Let's see. We also have a straight line here. And we have 130 plus 30, that would be 160. So we would take 180 minus 160, and that would give us the measure of angle 2. So 180 minus 160 is 20 degrees. Next, we'd use the exterior angle theorem for this entire triangle. So I'm talking about this large triangle of all the triangles put together. We know that it shows us that 8 and 1 are congruent. Our exterior angle outside of the triangle is 130. So 130 is equal to the sum of the two remote interior angles, which would be the measure of 8 plus the measure of 1. So the measure of 1 plus the measure of 8 is equal to our exterior angle of 130. And since those two angles are the same, let's just call them x. So x plus x equals 130, or 2x is equal to 130. So divide by 2, and x is equal to 65. So the measure of angle 1 and the measure of angle 8 are both 65 degrees. So from here, let's see, the measure of angle 2 we know is 20, so I'm going to put that in there. And 1 is 65. Now we can find 3. So this angle and this angle would add up to 85. So if I subtract 85 from 180, that would give me the measure of angle 3. So 180 minus 85 would be 95. Let's see, what else do I need? The measure of angle 8 is 65. The measure of angle 7 is 70, so I can find the measure of angle 6. So if I add these two angles together, that would be 135. And if I subtract 135 from 180, I would get the measure of angle 6. So 180 minus 135 would be 45. So the measure of angle 6 is 45 degrees. For number 39, the measure of the larger acute angle in a right triangle is 2 degrees less than 3 times the measure of the smaller acute angle. Find the measure of each angle. So if it's a right triangle, then the two acute angles must be complementary. So they must add up to 90. So our two angles, let's see, if we call one of them angle 1 and one of them angle 2, one of them, so we would just call it x, we don't know. And the other one, in terms of x, it says is 2 degrees less, so minus 2 from 3 times the measure. So 3 times x. So it is 2 degrees less than 3 times the measure of the smaller acute angle of x. So our two angles, 3x minus 2 and x, are complementary, so they add up to 90. So combine your like terms, you would get 4x minus 2 equals 90. So we add 2 to both sides, and we divide by 4. So we get x is equal to 23. So that would be the measure of our smaller acute angle, which is just x. And if we substitute in x here, we would have 3 times 23 minus 2. So 3 times 23 would be 69 minus 2 is 67 degrees. And just to double check, 23 and 67 are complementary. So we know we have the right answers. In number 41, triangle XYZ, measure of angle X is 157, Y is equal to Y, the measure of Z is equal to Z. Write an inequality to describe the possible measures of angle Z. Explain your reasoning. So we know that the measure of angle X plus the measure of angle Y plus the measure of angle Z must be equal to 180 by the triangle sum theorem. So if we subtract 157 from both sides, Y plus Z must be equal to 23. So let's talk about this equation and what Z is equal to. So if Z is equal to 23, then that would mean that Y is equal to 0, which is impossible. If Z is greater than 23, then that means that we would have a sum greater than 180, which is also not a triangle. So Z has to be less than 23. For example, if Z is 22, then Y could equal the measure, or could equal 1 degree. So 1 plus 22 is 23, plus 157 is 180. So Z has to be something less than 23. Number 43, we are given that RSTUV is a pentagon. We want to prove that the measure of angle S plus the measure of angle STU plus the measure of angle TUV plus the measure of angle V plus the measure of angle VRS is equal to 540 degrees. So we'll start by stating our given information. Next, by the triangle angle sum theorem, since we have this broken up into 3 triangles, we can say that these 3 angles must add up to 180, these 3, and these 3. So that would be the measure of angle S So I went ahead and took the liberty of numbering my angles here. So 1 and 2, 3, 4, 7, 6, and 5. So back to what I was saying. The measure of angle S plus the measure of angle 1 plus the measure of angle 2 is 180. Likewise, the measure of angle 3 plus 4 plus 7 is 180. And the measure of angle 6 plus V plus 5 is 180. So angle sum theorem. So if we took all of these angles together, added everything here, here, and here, that would be equal to adding these 3 together. So s plus 1 plus 2 plus 3 plus 4 plus 7 plus 6 plus v plus 5 is equal to 180 plus 180 plus 180, or 540. So that's just the addition property of equality. So we added like things to both sides of the equation. Now we want to say what some of these angles of the pentagon, what they're equal to, so we can substitute in our next step. So we have angle VRS would be angles 1, 4, and 5 added together. We also have angle TUV, this angle, we would get by adding angles 7 and 6 together. And we have angle STU, which we would get by adding angles 2 and 3 together. So that is the angle addition postulate. If we add these two angles together, we get this angle. Adding these two together, we get this angle, and so on. So finally, in the last step, we can substitute. So for back in statement 3, for angles 1, 4, and 5, we can substitute VRS for angles 7 and 6. So we can get rid of 7 and 6 and substitute TUV, and we can get rid of angles 2 and 3 and substitute STU. So that would leave us with the measure of angle S is left over. And the measure of angle V is left over. And then all these numbers go away and we get these angles in place of them. And of course that's equal to what it was equal to before, 540. And so that's what we wanted to prove, and we did that through substitution.